Okay, on number 59, we're trying to neutralize 50 milliliters of 0.200 molar NaOH. And the first one says, let's neutralize that with 0.100 molar HCl. So I'll do the first one all the way out, and I think you'll see how to set them up. So we're going to write the reaction. We have NaOH is going to react with HCl, and we want to neutralize it, which means that we're going to end up with water and a salt. And the salt will be the Na and the Cl. Now, we know for all of our problems, we have 50 milliliters of 0.200 molar NaOH. So this is very similar to our lab we just did. And in this case, we're starting off with 0.100 molar of HCl, and we're looking for the volume of HCl we need. So this is a stoichiometry question, and we talked in class about how it's sometimes easier to just know the number of moles instead of the molarity in the milliliters. So when you multiply those, this is equal to 0.01 moles, and there's 3 sig figs, 0.0100 moles of NaOH. That's what we're trying to neutralize. So we know in this reaction it's a 1-to-1. If I did the stoichiometry, we would say 0.0100 moles of NaOH. And I'm going to need 1 mole of HCl to react with 1 mole of NaOH. And so I know that I'm going to also need 0.0100 moles of HCl. And we're going to get that out of this concentration. So this is the number of moles. And the concentration, if we go back and use our molarity calculation, 0.0100 moles of HCl will equal the molarity times the volume. So we divide both sides by 0.100 moles per liter. And when you divide by moles per liter, the moles will cancel and the liters will end up on top, and you will get 0.100 liters of HCl, which is 100 milliliters. So that's the answer to part A. Now, we could do this all in one stoichiometry reaction, and we will do that later. I won't do that now for the sake of time. For part B, Part B on this question says we want to neutralize it using 0.150 molar of HNO3. So our reaction now is NaOH plus HNO3, and that's going to make H2O plus NaNO3. And that's balanced. It's all 1-to-1. And it says it's 0.15 molar. So this is 0.150 molar, but we still have 50 milliliters and 0.200 molar, so we still have 0.0100 moles of NaOH. Now we can do the same type of stoichiometry calculation, or we can just look at the reaction and say these are 1-to-1. So if I need to neutralize 0.0100 moles, I'm going to need 0.0100 moles of the nitric acid. Right? If we did it in stoichiometry, we would say this many moles of NaOH times 1 mole of nitric acid for every 1 mole of NaOH from the balanced chemical reaction means I need 0.0100 moles of nitric acid. And since I know the volume and I know the N, we know that the number of moles is equal to the molarity times the volume. So the volume is equal to the number of moles divided by the molarity. So we know we need 0.0100 moles to neutralize the acid, and we know the molarity is 0.150 moles per liter. And so when we do that division, we get 0.067 or 0.667 liters, or 66.7 milliliters. Sorry, I ran off the page there, but you can see the work. I'll do the next one on the next movie.